Great, thank you.
Thank you.
And our last finalist presenting will be Amanda.
Hello, my name is Amanda, and this is Michelle. She was my partner for the thesis. Say hi, Michelle.
Hi there.
Okay, Amanda, I've given you. I've given you control of the.
Sorry. Can I explain something really quickly? We are in the same workplace because we are on our lunchtime. So we're going to try to regulate the sound, okay?
Sounds good.
Yeah, that's good
That's
now.
okay.
Yeah, you stop the echo.
If everyone mutes except her,
Give me
we
a
should
second.
be fine.
I'm going to share my screen. Okay, can you see my screen?
Yes.
Yes.
Okay. Our work focused on proposed high-energy performance solutions for the Lab Zero building at the University of Brasília. For this presentation, first we will introduce the topic. Next, we will discuss zero-energy building in general and present the survey we conducted at this topic. Then we will explain the geothermal heat exchanger and solar chimney solutions. Lastly, we will conclude our findings. Our motivation was the continuous increases in energy demand and high greenhouse gas emissions, and our proposal was develop the HVAC solutions for the Lab Zero project, a new zero energy building to be constructed at the University of Brasília.
Our thesis is divided in three main parts: a statistical analysis of zero-energy buildings around the world, the design of a geothermal heat exchanger, and the design and simulation of a solar chimney. Starting with the statistical analysis, we did a research of 50 buildings to understand the main technologies used, the kind of cooling solutions to minimize energy consumption, the type of energy generation. We also did some research on the HVAC solution used, but we won't get into details here because we have to focus on the other topics, but we wrote another article about that. And now Amanda is going to talk about the geothermal heat exchanger.
The geothermal heat exchanger was designed for Lab Zero to cool the condensation water from the direct expansion and water-cooled AC system. For the design, we used analogy between thermal and electrical resistances and radial heat transfer equations. We considered three resistances, one for the water convection and two for conduction, one for the soil and another for the pipe wall. Through mathematical manipulations, we found the length of the pipe necessary for the heat exchange. Our calculations showed that we will need 640 meters of tubing to transfer the required amount of heat. We arranged the pipe in spirals, coils, and with two layers, which results in an area about 200 meters for the heat exchanger. Next, we create the isometric drowning of the piping and plant the valves in a way that allows the system to be used in various configurations, such as in series, parallel, or just one of the depths, the deeps. This flexibility ensures that the system can be adjusted according to operational needs and experimental conditions.
Now, talking about the solar chimney design, since the base project for the Lab Zero was already completed, we weren't allowed to choose a different type of chimney. It was defined that it would be a vertical model installed on the west side of the building. And what we did was to test different dimensions and analyze its performance. For that, we created a Python code using a mathematical model developed by Bansal, which has three main energy balance equations. One for the glass cover, one for the air between the glass cover and the absorber, one for the absorber wall. And with these three equations, we could solve a system which result in the temperatures for each one of those parts. And we were able to calculate the air flow rate for this chimney. For the results, first we need to validate our model. And we had to understand the behavior of the main parameters first to compare with literature. We test different dimensions for our solar chimney. Here on this first graphic, we have the solar radiation relation with the airflow rate. As you can see here that they are directly proportional. The other test was with the height of the wall. Using the same solar radiation, we can see that if we increase the height, we also increase the airflow rate. We also try to vary the other dimensions, but there wasn't like any significant results or changes. So that could mean a limitation for our model. But with those results, we were able to define the best dimensions to optimize our solar chimney. Sorry. And after that, we were able to simulate throughout a year and analyze its performance. Given that the building operates from 9 p.m. to 9 a.m. to 5 p.m., and consider that the solar level radiations, and consider the solar radiation levels, we were able to get those results here that shows the airflow rate throughout the whole year. It was possible to notice that most of the values are between 400 and 800 meter cubicles per hour. But we needed to validate those results to see it was satisfactory. So we used a document published by ANVISA, a regulatory Brazilian agency, that says that for air-conditioned environments, we need the air renew rate of 27 meters per hour per person. We converted this data for this second graphic here that showed the number of people that could be served with this airflow rate. And you can see that our solar chimney provide the necessary airflow in only 6% of the hours if the building is at full capacity. But considering that it won't be full at all the time, we did a test considering 20 people, and that number increased for 65% of the hours, and then to 15 people, and that number went to 95% of the hours. Based on these results, we were able to say that our okay, sorry. Based on these results, we were able to decide that the solar chimney was relatively efficient for the Lab Zero, considering that we will combine that with other solutions. And for the conclusions, our research of the net zero buildings was really important for us to understand the kind of HVAC solution and also decide what are the best solutions for the climate in Brasilia. The geothermal heat exchanger shows potential as a sustainable alternative, but we need to study a little bit more about the soil in Brasilia. That was one of our problems. And we also need to realize more simulations after the Lab Zero is built. As for the solar chimney, we want to do more simulations with our model, but we think when we combine with other technologies, it can be like a really efficient solution for the Lab Zero. And that's it. Thank you. Sorry, I was a bit nervous.
Thank you. Shall I start? This one. Thanks for that. Really interesting project yet again, and nicely presented.
1 second. We wasn't hearing you.
Can you hear? Okay. One of you will have to turn your microphone off, loudspeaker off, or microphone off, I think, or something. Stop your echoes. Anyway, great. Thank you. Let's. Obviously, the whole of this work is looking at energy efficiency. That's been your priority. But as we saw from that lovely photo of a trench with the slinky laid in it of the ground heat exchanger, there's a significant amount of money that needs to be spent on such alterations to a building. So I wondered whether you've done any sort of got any feeling of cost analysis of these lovely passive systems compared with just putting in a fan and drawing in outside air or something?
Sorry. Okay, so since it's an academic project and it will be built in our university, we didn't have to analyze the costs. Like they want to do it for study, you know?
Mm-hmm.
Like they heard about the results and what we can research using this kind of technology.
Okay, that's good. You've got to start with some basic research, and then you can look at the application. Thank you. That's answered that question. I may come back later after the other two have asked their questions.
Well, if I had a question about the heat exchanger too, which was, why did you choose the slinky? Well, actually, it's two questions. Why did you choose the slinky instead of doing deeper bores that would give you more favorable temperature, most likely? And in your schematic, did I understand that you have multiple levels of slinkies? It looked like you had circuits at different depths in that one figure that you showed us.
Okay, I'm going to translate because I'm a bit nervous. So basically, we choose the spirals because it would occupy less space. But we need like a really long pipes to fulfill the needs for the building. And yes, the idea was to do different levels for testing, like 3 meters and then 6 meters.
Okay, thank you.
Okay, jump in here. So first quick comment on the geothermal. You mentioned like not choosing a specific soil conductivity. It's been over 15 years since I've done geothermal design, but I remember we were really careful not to make assumptions until tests had come back. So checking a range was the right move. I agree with that. It's dangerous to make assumptions about what the soil is actually going to be and choose one value. Okay, having said that, so I really enjoyed the comparison of the solar chimney airflow versus how many people are going to be in there. Do you have any recommendations on how to augment that? I think Tim might have actually said something similar to this, but do you have recommendations on how to augment the solar chimney so it could adjust to however many people are actually going to be there?
Okay, that's a great question. I actually haven't thought about it. But since our solar team would be combined with other solutions, we weren't really worried with the regulation. Actually, the first idea was try to create a system to change the size of the wall, try to increase the size. But that would cost a little bit more. So we even talked with our advisor about that, if you could test it. But when the people behind the project, it's funny because like I was talking about the geothermal heat exchanger, and they weren't worried about the cost, like with the shoving. But with the solar chimney, they said we couldn't change the dimensions. We had to choose one and leave it that way.
There are other things that end up influencing the design. I hear you. Okay, thank you.
If there's time, I've got. I think we probably haven't quite used our 5 minutes up yet. I'll just ask on your analysis. You used Python and Design Builder, I think, as your tools to examine your systems. And I just wondered whether you performed any sensitivity analyses on the ground source heat exchanger and the solar chimney, just to see how the variations in the input parameters affected the performance of your predicted performance.
So can you repeat the last part?
Did you undertake any sensitivity analysis on your models?
Oh,
Your
yeah.
modeling?
Oh, yeah, guys. Yeah, we didn't have enough time to do that, actually. We had to choose like a few options for the dimensions to test it, but we not create a code like to optimize that like fully. I get it, but we didn't have enough time to do that.
Okay. Well, I mean, there's limited sort of time in a. When did you do this as a part of a bachelor's study or a master's course?
Actually, it's a bachelor study.
Yeah.
We had like a year to finish that. We started with one topic, and then we
covered a lot.
Another one.
You covered a lot of ground for a bachelor's project. Well done.
Yeah.
Okay. Well, that's it. I want to thank our finalists again. Good job to everyone. Once the judges have deliberated and have decided on a winner, you'll all be hearing from me soon.
Yeah, thanks to all of you. Well done. Very good work.
Yeah, thanks.
Right here
Thanks
in
very
the
much. Really good. Thank you.
Thank you all.
Thank you. Speak to you soon.
Thank you all for
Judges,
your
are we gonna
time.
stay on? Oh.
Thank you.
Thank you.
Thank you.